Hello guys, welcome to my fourth class. Means we already discussed basic statistics. After that we discussed mean. In the previous class in the mean I have only explained direct method. How to find out the mean for single values of the variables. How to find out the median, or how to find out the mean for discrete random variable distribution. How to find out the mean for classes, means continuous frequency distribution. Now, see here, other than that, we have other two methods based on the mean. Because whenever the data, we can't expecting always data, they give us only a small value. Sometimes x1, x2, x3 values may be in terms of hundreds, thousands or 10,000. In such cases, what we discussed in the last class is not useful to solve very easily. It's possible, but it's very tedious. Instead of that, we are going to use another two alternative method. Now I am going to discuss in the present class. Therefore, now the other two methods are, one method is method of assumed mean, another method is method of step deviation. Now these two methods are nothing but alternative method to find out the values of the mean or average. Another name of the mean is nothing but arithmetic mean. These two methods, just now I have told, whenever having the values of xi's are very huge values. Now in such cases, instead of using direct method, we are going to use either method of assumed mean or maybe method of step deviation. Now we have to know that what are the steps I have to follow. But suppose I have to use method of assumed mean. The formula for method of assumed mean is x bar equals a plus sigma fy ui divided by sigma fy. Sigma fy is also considered as capital N. I told in my previous class. Capital N denotes total frequencies. The small n denotes the number of values in the given set of data, where ui is xi minus a, where a is called assumed mean. This assumed mean occurs somewhere in middle of the given set of data. This assumed mean is also considered in some of the textbook provisional mean. It is somewhere in the middle of the values of xi. But generally we are going to take a assumed value. Usually we are going to take the value of xi is corresponding to the maximum frequency occurring in the given set of data. Means first you observe the frequency column. What's the maximum frequency? Corresponding maximum frequency value of xi is nothing but our a, means assumed mean. Once you take this, the next I have to find out ui and then multiply that and then I have to proceed. I am going to explain in further in the example. The next another one method is nothing but method of step deviation. Now the method of step deviation similar to the same formula for assumed, they are little bit different. The formula for this is x bar equals a plus summation fy di divided by summation of fy. The whole thing is multiplied by h. Now here h is nothing but Gaussian, where d is nothing but xi minus a divided by h. You compare this assumed mean formula and step deviation, and assume only we are taking deviation. Keep in mind, deviation is nothing but difference. We are taking difference from the assumed mean to the corresponding each values of xi. That is called deviation. That we are not considered only a deviation. We are also multiplied by or divided by whatever class interval or multiplied by reciprocal of the class interval. Then once you observe these two formula, once you take the deviation, again I have to divide it by the class interval. Compared to this ui value, this di values become very small value. Some cases, whenever we are using step deviation, no need to use a calculator. Without using a calculator, it's easy to find out what's the mean value, because of each of the value for di is given d2, d3 is a very simple value, it's reduced to very simple value, even though the beginning the value of xi is large value. This is the beauty of method of step deviation. I think everyone is clear where they are going to use these two methods. Next we have to consider example based on these two methods. Before going to take that, I want to highlight two notes. Note number 1 is actually just a few minutes I told already. Assume mean is generally corresponding to the maximum frequency. And then step deviation, just now we discussed, if you want to go for step deviation, always required a what actually h value. H is a what? Class interval. Now we can't go for always this method. This method is only allowed, the class interval must be equal. Means 0 to 10, 10 to 20 like that. Each of the classes are in the same interval. Such type of classes are nothing but equal class interval. Otherwise unequal. Whenever data in the form of unequal, this step deviation method is failed to give a answer or solution, correct solution of the given problem. Now let us consider one of the example based on the continuous frequency distribution. Continuous or group frequency distribution means the data in the form of classes. The following is the frequency distribution of marks obtained by 50 students in a test of statistics. They consider first row, instead of considering column, written in the form of row, that's marks and number of students. They given total is also, once you take number of students total, definitely how many students are expecting? 50. Calculate arithmetic mean by direct method, shortcut method and step deviation method. Now first, before going to calculate, first you consider the table. This is one of the important things that you observe while solving a problem from the statistics. Now what are the things you require? First you calculate in using table. Then once you use the table, you have to avoid the mistake, and also while in the examination also, construction of the table also, they are going to allot some marks. Therefore, first and third columns are nothing but whatever that first and second columns are first and third column are nothing but class and corresponding frequency. But we already discussed in the previous class of the mean. Whenever the given data in the form of classes, first you find out the mean values. 0 to 10, what's the mean value? 5. How to find out mean value? 0 plus 10 divided by 2. That gives us 5. Lower limit plus upper limit divided by 2. That gives us mean values. Similarly, we have to calculate this. Once you calculate that, next the frequency they give up. The first I want to find out direct method value. Therefore, what we are going to find out in the next column? Fi into xi. 5 into 4, 20. 15 into 6, 90. 25 into 20, 500. 35 into 100, 350. 45 into 7, 315. 55 into 3, 165. Immediately you find out total of Fi and Fi xi. Now the last row of each of the table is total. You keep in mind that is the total of each of the column. What are the total I am not required, I am not find out the total. What are the total are required to proceed for these three methods? Only I have to highlight the total, that's all. Direct method, what's the formula? X bar is equal to sigma Fi xi divided by sigma Fi. Now, sigma Fi xi is what? 440 divided by 50. Now using calculator, you calculate it, we get 28.8. And next, I want to find out shortcut method and step deviation method. Therefore, I am moving to the next step. What's the next column I want to find out? UI. What is my UI? Xi minus A. Now, A just I have to do, you go to the frequency distribution column. In the frequency distribution column, what's the maximum frequency here? 20. What's the corresponding Xi is? 25. Therefore, my assumed frequency in this problem, what's the value? 25. Therefore, what is that? A minus 25. Once you take A minus 25, Xi minus 25. What's the first value of X? X1, 5 minus 25. What we get? 20. 15 minus 25, 10 minus 10. 25 minus 25, 0. 35 minus 25, 10. 45 minus 25, 20. 55 minus 25 is 30. Then, I don't want this total, therefore I am not necessary to find it. I immediately have to multiply minus 20 into corresponding F1 value, 4. We get minus 80. 6 into minus 10, minus 60. 20 into 0 is 0. 10 into 10, 100. 7 into 20, 140. 3 into 30 is what we get actually? 90. Now, if you want to go for assuming a shortcut method that required a total, once you calculate the total, what we get actually? 190. And simultaneously, I have to calculate what about that step deviation. Now, before moving to the step deviation thing, immediately I have to calculate what is our shortcut method or assume mean. What's the value? X bar is equal to A plus sigma Fy Ui divided by total frequency means sigma Fy. You substitute A is 25 plus 190 divided by 50. You divide and then added 25, we get same answer 28.8. And then moving to the step deviation, anyway in this table we already calculated Ui. Therefore, just you divide Ui by the class interval. What's the class interval? How many values are counted in each of the class? 10. Therefore, this is an equal class interval. Therefore, it's possible I have to move for a step deviation method. Therefore, I have to divide minus 20 divided by 10, minus 2, minus 10 by 10, minus 1. 0 divided by 10 is what? 0. 10 divided by 10 is 1. 20 divided by 10 is 2. 30 divided by 10 is 3. Now, I immediately multiplied with corresponding frequency. 4 into minus 2, 6 into minus 1, 20 into 0, 10 into 1, 7 into 2, 3 into 3. Then we get immediately 19. Now, one thing we have to observe. Now, FIDA is very small value. We get only 2 units. Here we get 3 units. Now, 190. Here only a 90. Compared to this is a very small. That's why I told step deviation method sometimes without calculator is possible to find out because we get very simple calculation here. 90. What's the formula for step deviation here? X bar equals A plus sigma Fy di divided by sigma Fy into the corresponding class interval. And then to substitute these values, simplify, we get that. You just observe the difference between the shortcut method and step deviation method. Here in each of the UI I divide H, finally I have to multiply by the class interval. The beauty of this step deviation method is without calculator sometimes easy to calculate, even though it's a huge data. Now we get how to convert it to simple form. Complete these 3 methods, we get unique answer. Yes, suppose you did properly, correctly, without mistake, definitely we get same answer. Otherwise you don't get it. Now based on this, we are going to recommend whenever they are having a huge values for the given data for xi, better I go for step deviation method instead of these two. But disadvantage is the data must be whatever that is in which form we are expecting, the classes must be equal class interval. Otherwise, you can't go for step deviation method. Suppose you step deviation method, don't get it correct answer. Now, in my next class, I am going to consider another one example based on discrete frequency distribution. Thank you very much for listening my